Hey, so today we're going to cover just two topics. We're going to cover logical operators and we're going to cover how to use them in Python. Okay, so what are logical operators? We use them whenever we have multiple conditions, okay? If we want to create a complex condition, this is what we're going to use. So I know it might sound a little bit weird, but we'll get through it. The logical operators is just one of those things that you have to remember and you have to just learn it. There's no other way around it. So the three most important ones are and turns out true only if both conditions that we have are true. Then we have or turns out true only if one of the conditions is true. The other one can be false. And then not is going to just reverse the whole thing. So the whole result of your expression. So for example, if at the end of your expression you get true, if you put not, you're gonna have false. If you have a false at the end of your expression and you put not, you're gonna have true. So this is an example. For example, and example. If temperature is less than 20 and minutes are greater than 12, then display the temperature is in the danger zone. So you see how we have this and in the middle between the two conditions. We have a condition that's called temperature less than 20 and we have a condition minutes less than 12. These two are called the conditions, and this is our logical operator that's going to connect the two for us. Okay, so the computer will display the temperatures in the danger zone only if temperature is less than 20 and minutes are greater than 12. If minutes are less than 12 or if temperature is less than 20, this piece of code will be just skipped. Okay, so let's move on to the or example. So we have if temperature is less than 20 or temperature is more than 100, then we're going to display the temperature is in the danger zone. However, the cool thing about or is that it looks at each condition at a time. So we're going to look at if temperature is less than 20, and if our temperature is less than 20, we're not even going to look at this part. We're not going to look at the temperature is more than 100 because we don't need it. Or, remember, or only one of the conditions needs to be true. So if this condition, temperature is less than 20, is true, we're just going to skip this whole part of the code and move straight to executing what's inside of our decision structure. And same thing, if the temperature is more than 20, for example, then we move on to the next condition that we have, okay? If this condition is false, only then we move on to the next condition and check if this condition is true. So this is how the not logical operator works. And all it does literally just flips the value of your condition. So for example, we look at the condition, temperature is more than 100. Let's say today the temperature is 75, right? So our temperature is less than 100. So this condition is false because our temperature is 75 and 75 is less than 100. But since we have a not here, we will turn this false into true. Just flip it. So condition is false, we put not in front of it, it's going to flip the result. So we had a false and then we're going to have a true. And then since it's true, the code will execute. This is below the maximum temperature. This is what I was talking about when I was talking about the OR operator, the short circuit evaluation. So it is supported by many languages because it makes your life easier. For example, we know that the AND operator needs both expressions to be true, right? For it to be true. However, if even one of the expressions is false, the condition is going to be false. It doesn't matter. The condition is just going to be false because AND takes true and true to be true. Let me show you this. So this is our AND, right? You need true plus true will give us the truth, right? However, if we have false plus true, it's going to give us false. And it doesn't matter which way. So if we have our first truth and then the second one is false, that will still give us a false. Okay? That is why some languages if they see that the first expression evaluates to false, we're not even going to check the second expression, okay? Because it doesn't matter. It doesn't matter if this expression is true or false, because we will still end up with false because our first expression is false. And the same situation with the or operator, okay? Since or operator needs only one truth to get true result, if we have this, true plus false, we're going to end up with a true. If we have a false plus true, we're going to end up with a true. If we have a false plus false, we're going to end up with a false. And if we have a true plus true, we're going to end up with true. This is for the or operator. However, the same logic works for the or operator as we use for the and operator, because look at this. If we have the first expression evaluate to true, we don't need to check this one. We don't need to check the second one, because we're going to have the truth regardless of what this expression is. All right, range checking. Another thing that you just have to remember. So whenever you check for a number that inside of the range, for example, a number that's more than 20 and a number that's less than 40, right? A number inside a range from 20 to 40, we're going to use an AND operator. However, if we want to check if a number is outside of the range, if the number is less than 20 or more than 40, then we're going to use an OR operator. That's just another useful thing to remember and keep in your head. Okay, Boolean variables. A variable of the Boolean data type can hold one or two values, either true or false. Okay? We can change it to either true or false, but these are just two values that a Boolean variable can hold. So let's remember our data types. We have a string. String is a sequence of characters. We have an integer. Integer is a number, is a whole number. And we have a double. Double is a number with a decimal after it. And now we're adding a Boolean to it. A Boolean is just a variable that can either hold a true or a false value. All right, so let's look at Python and how do we implement the decision structures in Python. So these are all of your relational operators right here. Greater than, less than, greater than or equal to, less than or equal to, not equal to. And remember how I told you that the equal, if we want to check if two things are equal, we use the double equal sign, okay? Not single, double equal sign. And if we want to check if something is not equal to something, we use a exclamation point with the equal sign. So this is how our if statement would look like in Python. It's very useful. I am telling you to pay attention to this and maybe take some screenshots or look at the PowerPoints, because this part is very useful for the labs that are assigned for this week. So this is how we create a if statement here. If, then we have our expression, right? Boolean expression. For example, temperature is less than 40, or temperature is more than 70. It doesn't matter which, but we have an expression here. Then we have a semicolon, and then whatever we want the code to do, if this expression will evaluate to true. However, pay attention to this indentation right here. You have to have an indentation, because Python will not understand. If you're going to put your code right underneath the if statement, the Python will not understand that these statements are part of the decision structure. So you have to have the indentation. This is how we would write a if-else statement. Nothing crazy, nothing too difficult. Same thing, we start with an if, with our if, and then we just put the word else and a semicolon. And same thing, and the indentation, whatever we want the code to do. So the relational operators, we can use them to compare strings in Python and in any other language. Usually we can use relational operators. So here we have a variable called name1, and we assigned it the word Mary. Then we have a variable name2, and we assigned it the word Mark. So these are our string variables, okay? And we are checking if name1 equals name2. We're going to print the names are the same. However, we have an else. If the names are not the same, we're going to print the names are not the same. And let's see what this code will evaluate to, right? So let's see. We have Mary here and we have Mark. So what this language, Python, is going to do is going to take and is going to check character by character. So we're going to look at M, right? And we're going to take name2 and we're going to check for their first letter, M, right here. So we're done with these two. They're the same so far. We're good to go. Then we're checking the second letter, A and A. All right, seems good to me. They're pretty the same so far. Then we're going to check the third letter, R, and another third letter, R. Okay, pretty the same. I don't know what happened there. I'm sorry. This is M-A-R. They're pretty the same. And we're going to check the last letter, Y and K. All right, these two are not the same. So our names are not the same. So instead of going straight to this piece of code, our compiler will take us to here. And what we're going to do, we're going to print these names are not the same. Easy. So these are the logical operators in Python. And is a logical and, or is a logical or, not is a logical not. Nothing crazy, nothing difficult. It's just instead of using the capital letters, we're using the lowercase letters in Python. This is how it would look like with some code. So as you can see, if x is greater or equals to 20, and our logical operator, and x is less than or equal to 40. And remember, we are looking for a number in the range between 20 and 40. That is why we're using an AND, okay? X is in the acceptable range. See, the same thing was OR. X is less than 20, or X is bigger than 40. This is where we use our OR because we're looking for a number outside of range. And the same thing, if not, temperature is greater than 100. So if the temperature is greater than 100, this condition will give us false. And if the temperature is less than 100, it's going to give us true. Only because of this little guy, not. And this is how a Boolean variable would look like in Python. Same thing. See, we create a variable, we say a name of the variable, and then we assign it a value. It's either true or false. And remember, in Python, we do not declare the data type of the variable before, so it does not matter. So you just type whatever name you want for the variable to have, and then you assign it to it whatever value you want to assign to it. All right, I'll see you in the next lecture, and I hope you enjoyed. Bye.